In this video, we're going to discuss inverse trig functions. Learning objectives are understand the inverting process of trig functions and be able to evaluate inverse functions. Evaluate. So before we discuss inverse trig function, it is essential that you understand the concepts from sine, cosine, tangent function we learned previously. You also need to understand the unit circle and be able to construct unit circle. So for example, we did problem like what is sine of 2 pi over 3? Okay. So that means when angle is from here 2 pi over 3, what is a sine value? What is the corresponding height of the terminal ray, this height? Well, it tells from unit circle square 3 over 2. So in inverse trig function, we will go opposite. And I'll explain what opposite in a second. But for now, it's very important to know that important for you to know the unit circle because we're going to refer to unit circle in this section as well. So before we discuss inverse trigonometry function, let's look at what inverse function is in general. So for any one-to-one function, this is an important condition. For any one-to-one function, an inverse function, and this is a notation right here, f to the negative 1 of x. This is not negative 1 power. This is different from numerical exponent. This is special notation for inverse function. Is the inverse function. And the definition is that if I composite f of f inverse, I get simplified to x. Or if I do f inverse of f of x, I get x for all domain of f. Okay? So that's the formal definition. But how can we explain this process? What this is saying that when we're quote unquote inverting a function, what are we inverting? We're inverting domain and range. Or we can think as we're switching domain and range. Another important thing is that not all functions have inverse function. Only one-to-one functions have inverse functions. So therefore, in order to obtain inverse function of sine, cosine, and tangent, we need to restrict the domain of each trig functions. Because sine, cosine, tangent are not one-to-one functions. But so that we can have inverse function of these three functions, we restrict the domain, which means we only look at the area of a sine, cosine, tangent that are one-to-one and invert that section. So let's look at inverse sine function. Inverse sine function reverses, that's what the inverse is implying here, reverse the process of the original function. Thus, input value of the original function becomes the output value of the inverse function, and output value of the original function becomes the input value of the inverse function. Okay, so we call it inverse sine function. We also call it arc sine. Okay. And here's the main idea. The inverse function, both of these, we can write sine inverse of x, or we write arc sine. They mean the same thing. And the reason why we call it actually arc sine, and I'll explain that in the next page. So this accepts sine value as input, and output is the angle measure. Okay. So, me right here. We did previously how when we have a sine of something, this is the angle, right? Angle. And output, we get the sine value as an output. Now the inverse sine function, we're inverting these two things. So for arc sine, this, let me point out, this right here is the sine value. We input sine value for the arc sine, which when we're given a value will be just a number, real number. So sine value comes here, and output is the angle measure in radian. It can also be degrees, but in general we use radian. So that's the difference. So output, here's the important thing. The output for inverse sine or arc sine is angle. And that is why it's also called arc sine, because it produces the arc or the angle in radian that needed to get this sine value. Sine, oops, sorry, that's not the best. Sine of this value. So what angle do we need for sine to get this sine value? Well, that's the answer. Okay. And I'll do an example later, but this is the main idea of arc sine. Okay. So what are we switching? We're switching angle and sine value. So for sine function, input was angle, but now arc sine, output is the angle. Similarly, for sine value, output is sine value. For arc sine, input is the sine value. So that's the main idea. So, like I said earlier, we need to restrict the domain when we construct arc sine function. But the problem is there are multiple angle measures that produce the same sine value. For example, sine pi over 6 is half, sine 5 pi over 6 also half. And any angle that are coterminant to pi power 5 pi over 6 have the same output value of half. So this is a problem when we're inverting the process. Because, let me explain. Well, for sine function, it's okay that input gives us, the two different input gives us same value, or there are more, right? The infinite number of them will give us half as an output for sine value. But when we're inverting arc sine, oops, sorry, arc sine, let me make it bigger, arc sine. So if I follow this, if I invert it, well, it turns out if I plug arc sine of half, it gives me angle pi over 6. Well, this also, if I plug half, it gives 5 pi over 6. But this right here is not a function. The definition of the function, not just trig function, any function, is that for one input, in this case half, it should only give us a one output. But in this case, we get two output, right? So this becomes a problem for arc sine and actually for all inverse trig function. So that's why we need to restrict the domain of sine functions so that arc sine relations can be a function. A function. Again, function just means that if I plug one number, I should get only one value, but that's not the case here. But here you want to plug pi over 6, I got one number. 5 pi over 6, I got one number. It is okay that the output is repeated, but input cannot be repeated and give two different or more than one number as an output. Okay, so we restrict the domain. So here's a sine graph that we've seen before. If I invert this, we're not going to get a function. And let's label something. Here's the domain angle, and output is the sine value, right? Sine value is the output. So for example, when angle is 5 pi over 2, the corresponding sine value is 1, right? That's how we read the x and y axis, right? But like I showed earlier, this is not a one-to-one function. One-to-one function means each input must correspond to only one output. But that's not the case. Pi over 2 is 1, 5 pi over 2 is 1, negative 3 pi over 2 is also output of 1. So we need to restrict the domain. So we look at actually only this value, this section of the graph for sine before we invert it. So we're going to go only look at this section of the graph, like this blue part right here. We look at this graph and we'll invert this. Okay, so let me go to the next page. So let me make it clear. Here we have a theta. This angle is the x-axis. The y-axis is the sine value, right? So we invert this. And again, when I say this, we invert this portion of the graph. And what happens is that, again, we're switching the domain and range. So now this angle right here will become y-axis for inverse function. So here's the sine inverse function, arcsine, right here, the bottom graph. And as you can see on the y-axis, now this is the angle. The y-axis is the angle. And this value, the x-axis is the sine value. And this is the shape of the arcsine graph. So different from sine graph, the arcsine graph is not infinite. It does not repeat forever. Just literally just this is it. It begins right here and it stops right here. And so how do we get from here to here? You can think as we have a y equals x diagonal line and we rotate it along this line. You think as grabbing this part and rotate this way, like 3D, and then we get this graph. Okay. So this is the arcsine graph. So that means we can also read off from the arcsine graph. Arcsine, for example, what is arcsine of 1? It's pi over 2. So for now, important thing to remember is that for arcsine graph, domain is restricted. We cannot just look at any value. Range is also restricted. We just do not get all the values. That's really different from sine function where we can put any angles here. But for arc cosine, or excuse me, arcsine, we cannot put any value here. We can only put values from -1 to +1. Okay. So here's the formal definition of arcsine function. And we'll look at an example also. Inverse or arcsine. Okay, so they mean the same thing. We say both. You need to be able to come with the both phrase inverse sine or arcsine. So inverse sine function or arcsine inputs a sine value in the domain. This is very important. You need to remember this domain -1 and 1, and outputs the angle measure that produced that corresponding sine value from the angle range this. Okay, so this is very important. This range is very important. Okay, and this is a notation. So when you see a problem like this, evaluate arcsine of √3/2. Okay. This is what to remember. Again, the range is this, -π/2 to +π/2. That means the answer we get here must be in that range. So when you see this, this is implying this. You have to remember this. And I suggest you actually writing this down once. This is asking this, quote unquote, find the arc, or we can say angle, find the angle whose sine is √3/2 between the angle -π/2 and +π/2. So that's what this is asking. So knowing sine inverse includes knowing this range. You have to remember this. Just find, when you say evaluate this, you have to remember this, because it's a part of arcsine function. So then let's go back to the question. Then what is arcsine of √3/2? Okay. Well, we look at the unit circle. Let me draw maybe quickly right here. We're only looking at -π/3. Sorry, -π/2, +π/2, not -π/3, -π/2. So we're only looking actually the right half of the unit circle only. And √3/2 is right here for sine. This we get half and √3/2. So what is this angle? Well, that angle is π/3. And π/3 is in this range. So we get only one answer of π/3. So if you write two answers, that's wrong, because that means we're not understanding arcsine as a function. You only get only one answer for inverse trig function. Just like any function, when you input a number, you get only one angle, one output. Okay. So remember, let me emphasize this one more time. You need to really remember this phrase. Find the angle whose sine value is square root over 2. That angle is between negative pi over 2, positive pi over 2. This is part of knowing what arcsine is. So then let's look at inverse cosine function. It's very similar. The idea is very similar. We're just inverting the cosine. Uh, reverses the original function. Okay, so for inverse cosine function or arc cosine function, accepts the cosine value as its input, and output is an angle measure that produces that cosine value. And similar to arcsine, the same issue happens where we have a values that, okay, if I put cosine pi over 6, I get this square root over 2. If I plug cosine 5 pi over 6, I get square root over 2. And any coterminal angles to these two, right? So we need to, again, restrict the domain of cosine functions so that our cosine relations can be a function. Okay, so this is very same concept from the arcsine, right? So for arc cosine, this is the cosine graph. It looks very similar to the sine graph, but it begins right here, right? Well, not begins, but it has a y-intercept at 1. So again, input is the angle, output is the cosine value. But because it's not one-to-one function, we need to look at only one section of the graph. So for cosine, we look at actually from here to here, this section of the graph. Okay. So right here, we look at this section of the graph of cosine, and then we invert this. Okay, we invert this, so then we'll get this. Okay, so let me write it again. Very important. X-axis for any graph is always wise to remember what x-axis represent, what y-axis represent. Angle, cosine value. Now, angle is here, and cosine value is here. So this right here is our cosine graph. Our cosine graph is not infinite. It doesn't repeat forever. It's just literally this portion. Just this is it. I shouldn't even say portion. This is the arc cosine graph. Okay, it's finite. It begins here. We can think it ends here. Okay. So let's look at the formal definition of inverse cosine function. Inverse cosine function, or arc cosine, inputs cosine value in the domain -1 to 1, and output the angle measure that produce sine value from range 0 to pi. Now, range is different for arc cosine and arc sine, so that's very important. Okay, so note two different range. So what is this asking then? Now, this question is asking, what arc, what angle do I need for cosine to achieve square 3 over 2? That's what that's asking, right? And also implying this range. So answer you get, evaluation you get for this must be between 0 and pi. And only one answer because it's a function. So let me write this. Find the arc, or we can call it angle, whose cosine is square 3 over 2. And that angle is between 0 and pi. So knowing 0 and pi, or I should say, knowing our cosine function includes 0 and pi. You must remember this. So what is the answer to this, our cosine? This is why we need to know the unit circle very well. If you look at the unit circle, 0 to pi. So we're only looking at the top half of the circle now. Okay. And square 3 over 2 is here for cosine, and this is half. This is cosine value. So to find this angle is pi over 6. So we just evaluate our cosine as square 3 over 2, which is pi over 6. So knowing unit circle and knowing the range is very important. So let's look at inverse tangent function. So inverse tangent function, similarly, same inverting process. This is the same prompt explaining what inverse process is. But of course, for inverse tangent, we're looking at slope and the angle measure. Right? So output is always angle measure for inverse trig function, and input is whatever corresponding inverse trig function. Okay. Similar challenge happens where for tangent power 4 is 1, tangent 5 power is also 1. So we need to restrict the domain of the tangent function so that we can have an inverse function. So here's a tangent graph that we've seen before. So here again, this is the angle. This is tangent value. So for example, when tangent of pi over 4, we'll look at here, since here's pi over 2, pi over 4 is half, this is 1. This means that for angle pi over 4, the terminal ray of that angle has a slope of 1. That's what tangent is, right? So pi over 4 looks almost like this. This slope is 1. That's what tangent function is. So inverse tangent function will input slope or tangent value as an input and get pi over 4 angle as an output. But when we graph tangent function, inverse tangent function, again, we only look at this portion. When we look at this portion of the tangent, we invert only this. So portion of the tangent function to invert it. So then we get this graph. So this is the graph of, let me label again. Here's the angle. Here's the tangent value, which means slope. For inverse tangent, we get angle as y-axis as an output. Input is the tangent value. So inverse tangent function actually does go forever in terms of range. Or excuse me, in terms of domain. Okay, not range, domain. We seem to remember a restricted range for tangent function, inverse tangent function. So here's the formal definition of inverse tangent function. Inverse tangent function, or arctan, inputs tangent value in the domain, can be any value, but output again is an angle measure from this range. So inverse tangent function's range is same as the inverse sine function. So when we look at a problem like this, okay, let me write the prompt. This is asking find the arc angle whose tangent is 1 between negative pi over 2 and positive pi over 2. So knowing arctangent function, includes this range. Very, very important. Okay. So let's actually evaluate arctangent of 1. This is asking what value do I get? What angle do I need so that tangent of that angle is 1? And the angle must be negative pi over 2 and positive pi over 2. So when we look at the unit circle, we only look at right half, negative pi over 2, positive pi over 2, and slope is 1. If you look at this angle right here, which is pi over 4, we get square root of 2 over 2, square root of 2 over 2. And sine divided by cosine can be used to find the tangent value, right? So this same number, so if you divide these, we get 1. So what is this angle? The unit circle is pi over 4. So unit circle is very important when we evaluate inverse trig functions. So let's look at that this one last example. True or false? Sine negative 1 power, sine inverse function is same as 1 over sine x. The answer is false. Okay. Because sine inverse is arcsine. So this is just to highlight that this -1 power is not 1 over something. Okay. For trig function, notation is different. Okay. Or if you see any notation that's f of -1, this means inverse function of any kind. 1 over sine x, we know that 1 over sine x is the same as what? Cosecant, right? So they're not the same thing. So be careful with the notation.